Hello students, welcome to the lecture. So students, as we know that we have started the static part of various topics, and in the previous lecture we have started the static part of general science and we have covered till physics. So in this lecture we are going to start with the chemistry part. Okay, so let's start. So again here I will tell you two main things. First is questions are directly asked in the exam from these topics. So it is the first thing which I would like to tell you. Second thing is that we will also do the revisions. Okay. So first we will learn the topics from which the direct questions asked in the examination. Second, we will also do some revisions. Okay. So let's start. So first we are going to learn about the metals. But before we must revise the elements. Okay. But first of all, we should revise the thing which I have told in the previous lecture, that elements are divided into three parts: metals, non-metals, and metalloids. Elements are basically get divided into three parts known as metals, non-metals, and metalloids. So now the question is, who was the person to divide element into metal and non-metal? So now this is the question I'm asking you. Who was the person to divide the elements into category of metal and non-metal? Okay. So we could say that we only knew about the element, but thereafter there was one person whose name was Antoine Lavoisier. Antoine Lavoisier. He was the person who divided element into three parts named as metals, non-metals, and metalloid. Metals, non-metals, and metalloids. Got it? But here I would like to tell you one more thing. Which is that Antonio Lavoisier just only divided elements into two forms: metals and non-metals. Okay. But who divided the elements into metalloids, or who discovered the term metalloids? So the answer is Simon and Irman. Okay. These were the ones who discovered the metalloids. So just write down these facts. All right. Thereafter, if we talk about which are metals, then basically you can say they having several qualities, like they are sonorous, they are malleable, they are ductile, and they carry iron percentage, and they are shiny also. So these are the qualities of the metals. First thing, they are sonorous. It means they produce sound. Okay. Thereafter, they malleable. It means that they could be easily turned into sheets. Okay. Thereafter, they are ductile. It means they could be easily turned into metal wires. And they carry the iron percentage, and also they are shiny and lustrous. Okay. So these are the characteristics of which? Metal. Got it? Now, what are non-metals? Non-metals are basically opposite of metals. It means that they are non-sonorous, they are not malleable, they are not ductile, okay, they are not shiny and lustrous, except only one non-metal, which is the iodine. Okay. Also, non-metals are poor conductor of heat and electricity. Okay. Except only one, which is the graphite. Okay. Whereas the metals are good conductor of heat and electricity. Alright. So this is about the metals and non-metals. Okay. Now, if we talk about then what is the meaning of metalloids? So basically you can say metalloids are those which having characteristics of both at some extent. Okay. So metalloids are those which having characteristics of both at some extent. Got it? Now let's have a discussion about the static part of metals. Okay. The first is osmium. The osmium having the highest density. Now my question is, what is density? And also I will ask a question which I forgot in the previous. First, you need to answer me the density. I am providing you 15 seconds to think about it, and your time starts now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Time's up. So basically, density is area occupied by particles on per unit basis. On per unit basis. So the area which is occupied by it is the occupied by particle on per unit basis is the density. Like if there are two figures we having, one is this one is this one, and now I am asking you which of the following having more density. Then what should be the answer? You will say this one having more density. Why? Because the area in between them is too slow. So that's why their per unit basis area is very less. Whereas if you looked at this picture, you will find they having low density because the area in between them is not so compact. Okay, so that is the definition of density. All right. Now the second question which I said I will ask you is that Lavoisier, the person who divided the elements into metals and nonmetals. So my question is, Antonio Lavoisier is well known for his nickname in the field of chemistry. Now you are required to answer this question, and I will provide you around 30 minutes, 20 minutes to think about it. Okay, so your time starts now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Time's up. Lavoisier was well known for his nickname in the field of chemistry as father of modern chemistry. This thing I have told you in the previous lectures, if you remember. Okay, and this is important. All right. So Antonio Lavoisier is also known as the father of modern chemistry. Got it? Now, let's come back to the topic. Osmium is the metal which having the highest density. Lithium is the metal which having the lowest density, and lithium is basically used for lithium ion batteries. Lithium is basically used for lithium ion batteries, which is very essential for electric vehicles. So this is an important point. Okay. Thereafter, tungsten is the highest melting point metal, which having the highest melting point. Okay. So that's why it is used in bulb filament and barrel of heavy guns. Okay. Because tungsten having the highest melting point, so that's why it is used in bulb filament or barrel of heavy guns. Okay. Thereafter, the silver, highest electrical and thermal conductivity. Okay. So which element having the highest electrical and thermal conductivity? The answer is silver. Now let's move forward. Thereafter, the gold. The gold is the most malleable and ductile metal. Okay. Gold is the most malleable and ductile metal. All right. And remember one thing. Have you heard about the earthquake? Is the basic shaking of earth surface. But you know, this earthquake can also do a miracle thing. The answer is yes. Now the question is, what is that miracle thing? So basically, it can transform water into gold. Yes, the earthquake can transfer water into gold. All right. Thereafter, we having the platinum. So platinum is basically the least reactive metal, or you can say also the inert metal. Do you remember in the previous videos when we were discussing about the periodic table, then we had a discuss of inert gases. Inert gases, the gases which are chemically stable. Okay. So in terms of the solid items or the metal items, platinum is the metal which is the least active or basically the inert metal. Okay. Thereafter, we having the mercury. Mercury is basically, you can say, metal which is liquid at room temperature. Mercury is the metal which is liquid at room temperature, also used in thermometer. All right, and it is the only metal which forms the amalgam with other metals. All right. Thereafter, tungsten, the same which we have covered here, is used in the electric bulb, as I have told you. Thereafter, we having the aluminium. It is the most commonly found in earth crust. Okay. So if we talk about all the three layers of earth, which is crust, mantle, and core. For crust part, it is Sial, it is Sima, and Knife. So basically, Sial stands for silicon and aluminium. Alright. Sima stands for silicon and magnesium. Knife stands for nickel and iron. Alright. So just note it down. Crust is Sial, basically silicon and aluminium. Mantle is Sima, basically silicon and magnesium. Core is Knife, basically nickel and iron. Alright. So you can say aluminium is the most commonly found in earth crust. Silicon is not count here because silicon is non-metal. And we are talking about only metal. Alright. Thereafter, what is tempering? So tempering is basically heating and cooling of metal to change their physical properties without changes shape. Okay. So tempering is basically the heating and cooling of a metal to change their physical and chemical properties. So if the question asks which process involves heating and cooling of metals without changing the shape but changes its physical and chemical properties. Okay, so the answer is tempering. So tempering is the process in which heating and cooling of metal is done to change their physical and chemical properties, but without changing its shape. All right. Thereafter, the next process is the hardening. It is the heating and cooling of material to make it brittle and break down easily. Okay. So if we go back to the previous topics which we have learned so far, so we know metals is a solid item and solid items having atoms placed together or placed closely. Remember? So in the previous lecture, I have told you whenever the temperature goes up, velocity or basically kinetic energy of atoms goes high. This thing I have told you in the previous lecture. Okay. So when we were hardening is basically when we were heating the atoms at the first stage. When we are heating the metals, then what will happen? Their atoms will start moving here and there. Okay. So what will happen? The breakdown of metal will become easy because now its atoms are far apart than they were. Okay. Thereafter, when we done the heat, the changing of the shape and all these things, then we start cooling it so that when the temperature goes down, kinetic energy will also goes down so that the metal will take the shape which we have provided him. Okay. Thereafter, the next is the galvanization. So basically what happened, I'm asking you a question like it is a iron rod. It is a iron rod. And if you have left it in open area or in open air for some time, what will happen? You will find that this rod is downgrading or rusting basically. Okay. Now the question is why? So I hope you all are remember the oxidation reaction and the reduction reaction. Oxidation and the reduction. So in oxidation reaction, generally we get the oxidization. In reduction, we generally loses the oxygen and gets the hydrogenation. That was the process we have learned in the previous sections. So basically, in the case of rusting of iron, what will happen? Oxidation will happen. The present oxygen of the air will react with this iron rod which is being kept in the open area, and due to this the chemical process will start and the iron rod will start downgrading. All right. So to prevent the iron rod from this, we generally do galvanization. And galvanization is nothing but a coating of zinc on iron strips. So that's how we cover the iron rod by zinc so that the oxygen particles of the air are not able to downgrade or to react with iron rod. Okay, we generally do zinc coating on the iron rod during the galvanization so that the oxygen particles present in the air does not get reacted with the iron rod. Okay, thereafter the next process is annealing. It is a process where metal is heated to a specific temperature, cooler, and then allowed slowly cooling to reduce hardness and increase ductility. I have told you ductility is basically the power of metal to be divided into firm metal wires. Okay, but for this, how you will do it? Like if I am giving you this block of metals, Okay, you will get this block or this box of metal, and now I want you to divide this block into a thin wire. Then how we'll do it? So first of all, you require change of shape, and for this you have to reduce the intermolecular force of these atoms of this metal block. And for this, what you will do? Whenever temperature rises, what it having the effects on intermolecular force? The intermolecular force will goes down. All right. So when you start heating up, its force will goes down, and then it is easy to divide it into firm metallic wires. Okay. So this process is known as annealing process. All right. Now let's have a look on elements. Now my question is, what do you mean by elements and compounds? What do you mean by elements and compounds? Again, I'm providing you 15 seconds to think about it. Then I will provide you the answer. Your time starts now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, time's up. So, if we talk about the elements, then they are single substance or pure substance having single type of atom. So basically these are the single substance or the pure substance having single type of atom. Whereas when we talk about the compounds, then the compounds are basically mixture of elements and having more than single type of atoms. Okay, so when we're talking about the elements, then they are the single substance or the pure substance which having single type of atom. But when we are talking about the compounds, then they are the mixture of elements which having more than single type of atoms. All right. So now because we are going to talk about the elements, then we are going to talk about both metals, non-metals, as well as metalloids. All right. So first we have the bromine. It is the non-metallic element liquid at room temperature. Okay. And when we talk about the mercury, then it is the metallic element which is liquid at room temperature. So remember, if we talk about the non-metal which is liquid at room temperature, the answer is bromine. When we talk about the metal which is liquid at room temperature, the answer is mercury. Thereafter fluorine, it is the most reactive element. Fluorine is the most reactive element. All right. Thereafter, we have the iridium. It is the most corrosion resistant element, not affected by water, chemical or acid. Okay. So iridium is the most resistant element. It generally does not get affected by water, chemicals or acid. Thereafter, we have helium. It is the lowest melting and boiling point, and it is the gas. Okay. Thereafter, we having the carbon. We have learned about in the previous sections as well. It is the element with the highest melting point, and it is basically the non-metal. All right. So iridium is the most corrosion resistant element. Helium, which is the gas, having the lowest melting and boiling point. Then carbon, which is the non-metal having the highest melting point. Alright. Thereafter tungsten, element with the highest boiling point. Also it is the element having the highest melting point. Okay. Then the osmium, it is the element with highest density. Then hydrogen, it is the element with lowest density. Okay. So students, in this lecture, we have covered the several part of static chemistry. In the next lecture, we will continue with this chemistry part. Okay. But till then, just revise all the facts which we have discussed in this lecture so that you will be able to learn about in the previous sections. So students, in this lecture, we have covered the static part of chemistry to some extent, not finished. In the next lecture, we will continue with the chemistry. Till then, just revise all the facts we have discussed in this chapter so that you will be able to grasp the facts more effectively in the upcoming lectures. Okay. With this note, end this lecture and thank you.